Okay, microphone. Uh-huh. Hello, dear everybody. Hello, my name is Dr. Kobkrit Viriyayudhakorn. I am your lecturer for instructor for the ET 63 ET 630, the special topic in the electrical engineering, and the topic that we are using here is the introduction to the artificial intelligence. This handout is printed on the paper and is available to you in the copy center. But in fact, I gonna to give you in the digital versions is the this all my material here is written by using the co-laboratories of the Google's. Okay, is co-laboratory of Google is something similar to the Google Doc, but for is similar to the Python notebook. Okay, it's similar to the Python notebook that you can actually write down some markup, some HTML inside that, and as well as the code. For example, here, in fact, I write down as a markdown markup into making this this lecture note, and also I can input the code as well, something like this. This is the code that I write, and I'll be able to run it to show you in real time at the results. And this code is putting down the YouTube, okay? And in the lecture, we are going to making the neural network in this notebook, okay? Which is very convenient for you. You don't need to set up anything because we based on the Google collaboratories. The Google collaboratory is allow me to it's on the Google Drive, okay? And it is very nice. I can have code snippet here ready for doing a lot of things. Something like I can install Keras here. I just click and it's installed for me. Something like that. This is the better way than just the PowerPoint, okay, for deep learning. Okay, and the link of this is here, okay, bit.ly/2FPFEZQ, and yeah, this is have the capital F and C, okay, so you can go to open your laptop and play around with it all together. Okay, so it will look like this. So when you get this something like this, and then you just click open. Well, I think you need to sign in to open it, and yeah, so you can using the Python notebook, and you can using it. Okay, when you got the notebook, you have this screen, right? This, and in this part, you can this is the HTML. No, it's a markdown markup. Which, if you want to edit some code, you just double click the blocks, double click like this, and you can change anything you want. Okay, and then when you finish, you just click at another box instead, something like this, and you can edit it. Okay, to run a box, you just pressing Shift Enter. It's gonna be compile the source code in this block and gonna run it and show the output for you. Okay, so you remember Shift Enter to execute the code in a block. Okay, and here something like this. This code is already run, right? So I Shift Enter. It's gonna be run. The code is gonna be pushed to the Google Cloud Engine, and then they execute the code and then they return results back to the collaboratories. Okay, and like this one, we're gonna have a course soon. in where is the video? I put a lot of video, I think. Here, something like this. Okay. So I put enter. It's gonna be generate the video for me. Okay. And this is how to use collaboratory. Okay. So good material for you to start learning deep learning. Okay. So we start here. We study in this room 3206. Okay. In the Thursday afternoon. Okay. And the instructor is Dr. Poon, Dr. Saphalit. He is, I believe that he is the top deep learning computer scientist in Thailand. Okay. He have published the paper and have the citation about 1,000 already. So he is super researcher. And he will be our instructor after the midterm. Okay. For myself, I am Dr. Kobkrit. Okay. I will teach you from the first day of the class to the midterm. Okay. So here is the table of content. We're gonna have the a lot of week. Okay, about 10 weeks before the midterm, but we got a lot of holidays. Okay, in the third and the fourth week, we will have the university sport day, and we will have the holiday here. So yeah, we will have about 7 weeks to learn about the basic artificial intelligence and deep learning. And after that, Dr. Sampalit will take care the topic that is quite hard. After that, okay. So the book that I want to have the full screen here, so I think I can. Oh no, full screen. Okay, the book that I'm using as reference is Deep Learning, written by the Ilan Goodfellows. Okay, the Ilan Goodfellow is the inventor of the GAN. Okay, if you know him, he just about 30, but he invented GAN. So he worked for Google right now, and also the OpenAI organization, which Elon Musk is the owner. Okay, so this guy is quite big in the field. And yeah, this book, why I choose this book? Because this book is very good and free. Okay, so you can get them in the HTML version or PDF version from both of link if you wish to. Okay, you can running without losing any cent. Okay, so this for the guy who enrolled in this class, I think we have 7 people, right? But only 4, right? Who grade this class, right? Please hand up who is the 4. This 4? Okay. Yes, good. Okay. So this is, in fact, this is my first time that the sit-in student is more than the actual enrolled student the first time. But okay, I have very good feeling on it. Okay. Okay, and we have the grade here. This is we will having an assignment for 10%. Okay, and we have the attendance for 10%, midterm and final exam. Both are 40%. Okay, and the midterm will be done on the 22 March of 2020, and the final of the 24th of May 2017. Okay, that is our total introduction of about the cross legislation and the material things. Okay, if you have any question, you can hand up and ask me anytime when I am explaining things. Okay, to help you to easier to understand it. Okay, so I need to learn from you as well, okay? To know that which part you don't understand, which part you want to clarify, you can tell me, okay? So our goal is to be able to make you understand on a deep learning and how to make it, how to develop this, how to become expert in the deep learning fields. Okay, let's start on your introductions. The AI and deep learning, okay? So the AI, when we start at the beginning, so I think at the moment that about the computer is invented in the Alan Turing, right? In fact, we as an inventor, so we really want to create a machine that be able to think by itself, okay? Be able to become intelligent and to help us to do the intelligent tasks, okay? When the programmable computer is invented, okay, it takes about 100 years to become intelligent, okay? The AI is the field to trying to make is a field for making the intelligent applications in the topic of something like automate routine labor. That is a goal that we want, that we create a computer, okay? And we want the computer to be able to understand a speech or image. We want to be able to make diagnosis in the medicines. The computer here, the intelligent computer here, be able to support us the basic research, okay? And this is, I think we pray later. I think I focus on this. First, I want to clear the file topic first. Okay. The tasks that we can provide to the computers can have into the two kind of the tasks. Okay. The first one is an abstract task, and the second one is a formal task. Okay. In the early days, the computers can, in fact, can rapidly run according to the command very precisely, accurately. Okay. In the early day, the computers they've seen invents, they are very good at the formal tasks. They are very good at solving the problem that can described by the list of formal mathematical rules. Okay, something like is a mathematical rule, something like formal tasks. Okay, and you can write them to counter something like creating the stopwatch, something like that. You can write the very easy task for them to say that, okay, every 1 second pass by, you increase by 1, counting the number of circles, the seconds, something like that. This formal task like this, the computer is very good at it because they are endurance. They are not like the human. They always stick to the rule. They always formal and no complaint. Oh, I do too much, something like that. The computer can solve this part for us very well. But the another kind of task that is a true challenger for the AI, artificial intelligence, is the task that is easy for people to perform, but very hard to describe formally to the machine. The problem that we can solve intuitively, and it's something like abstract tasks, something like be able to recognize the spoken word, be able to recognize the face in the image, something like that. We cannot describe this kind of problem formally in the mathematical group, something like that. So the abstract task is challenging and is gonna be the AI is gonna be better and better to solving this abstract task because of deep learning. Okay, and this kind of two tasks is become the key difference that you need to be able to differentiate. Okay. Um, to create the intelligence computer, okay? So we are going to work through the short history of the artificial intelligence, okay? When we start at the beginning of the intelligence computers, the intelligence computer is very well known for the early success case of artificial intelligence is something like the tasks that they can solve is a very formal task that did not require to know much about the world. Something like the shared AI, okay? Something like Deep Blue, IBM Deep Blue. What they only know is they need only know the rule of the chess, okay? And then the movement that the opponent move, okay? Their world is just the metric of, I don't know, 9 multiplied by 10 multiplied, and I don't quite know the size of that. That their world is only that. They don't know the city, they don't know the another concept. They just know that their world is just the metric of numbers and how to, and we have this rule and we need to follow this rule to win the game. Okay, that is the formal task, that strongly formal task. They in the early age of the AI, which the high computation powers, they can try a lot of possibility of the solution and be able to defeat the world championship in 1997. Okay, so this is the beginning of AI, the AI that for the formal tasks. But at that period of time, for the abstract tasks, they are very bad at it. They don't even recognize the characters. They don't recognize the face of people, and they have the attempt to, according to the size of knowledge the computer knows, is very small. The only way at that time that the AI can learn about the outside world is via through the formal simple rule that the programmer, the human supervisor, input it to them. Okay, so this is and we have very, they know much compared to us. Okay, and the next period, the computer scientists try to solve that, try to inputting the knowledge to the computers. They doing it by using the hardcore complex knowledge. Okay, the first they're trying to create the formal rule and formal method to trying to represent knowledge of the world into a sequence of the rule, okay, to a list of the rule, and we call it knowledge-based AI approach. Okay, the best example of this one is SIIT. The SIIT engine is the inference engine that have the database of the statement, okay, called SIIT language. Okay, so people putting the formal rule into the computer knowledge, okay, but they are not good because in the practical, because the very popular case of the fail of the thing is they not be able to understand a story of person named Fred shaving in the mornings. This is a very simple concept, right? But the interference engine, it failed to understand it. Why? Because it's the interference engine, they interference and they detect the inconsistency in the story. Because it's known before that by the rule, they say that the people do not have electrical part. But because of Fred was holding the electric slicer, right? It's believed that the entity Fred was shaping is contained electrical part. Therefore, they ask the human supervisor that Fred is still the person why they are shaping, something like that. They try to write down the hard code knowledge into knowledge-based computers, and they try to interference the statement that we put into it. But is still not good, okay? And it's kind of confused. So it's still not good because it makes human supervisor to input the knowledge into them. And this is the SIIT website, okay? That they try to make a biggest knowledge base error about our world, okay? But still not so successful. Okay, so they have another guy say that since humans trying to create a rule into the system and it's not good working, why we not use the system be able to capture the knowledge by itself? Okay, so we give them the data, okay, and let them extract the pattern from the raw data by itself. Okay, and at the previous stage, as the previous era is a hardcore complex knowledge. Is people, the human supervisor, capture the pattern in the nature and write down by itself into the machine, write down by their own rule into the machine. But yeah, the rule is called inconsistency, and we have a problem. So somebody said that, okay, let the machine have the sensor to the nature by itself. Let them acquire their own knowledge by extract the pattern by themselves. Okay, and this is the beginning of the machine learning. Okay, the machine learning is enable the computers to retrieve the knowledge for the real world and making decisions that appear subjective. Okay, for example, the logistic regressions. The logic regression is first proposed to let the doctor to tie down the condition of the pregnant woman. Okay, something like how big of the stomach right now, and a lot of any property. So how many months that they are in the pigment period, something like that. What is their rest? What is something like that? And the first application of the logistic regression is can determine that whether or not to recommend this pregnant woman to have the cesarean delivery, so the operation open the stomach, okay, or not. This is the first kind of the kind of the machine learning algorithms. And another one is something like naive Bayes algorithm, which catching the pattern in the email and be able to separate the spam email from the normal email that we want to receive. Okay, so with the machine learning era, the computers can capture the pattern by itself, and we can split into the classify all number, and they have a lot of machine learning activity happen here, very boom, and we have classified the machine learning tasks into three main class by looking in the input. Okay, the first one is the supervised learning. The supervised learning is we supply the AI both input and the desired output that we want them to know. Okay, so we provide them as a teacher. So we give them both input and output, and then let them learn from the data that we provide. And in the supervised learning can be done in many applications, something like classifications, maybe regression, something like that. Okay, classification is they can classify that something belong into the class, and in regression they can predict the value in the futures. something like predict the price of the stock market. This is the regression. Okay. And in the supervised learning, they have the two subfields, which is the first one is the semi-supervised learning. That is, they providing some part of the supervised learning in the data set, and then we give the incomplete training set for them and let them learn from it. Okay. And another one is active learning. Is the computer can obtain the training level from the limit set of the instant. So it's normally that we have the data. Okay, we have the data, and then we don't have the label data yet. We just have the features, but don't have the output class. We don't have yet. The active learning is interact with the human supervisor all the time to let human supervisor to tell them a bit by bit on tracking the data. Okay, so this is the part of the supervised learning in the machine learning. And the second big subclass or the second class of the machine learning is this is the reinforcement learning. Okay, so we give them the training data in both of the reward and punishment. Okay, and given back only the feedback to the program actions in the dynamic elements, such as the autonomous driving, such as playing game AI, something like that. These are fall under the reinforcement learning. Okay, and the last one is unsupervised learning. Is we not give any label of the target class for them. They just learning from the instance that they given, the input that they given by human supervisors, and then they try to discover the similarity, the similarity pattern, and to grouping the instance by itself. Okay, for the unsupervised learning, is very good for the clustering. Okay, and this is the summarization of what is the machine learning consists of. Okay, they have the supervised learnings, they have the unsupervised learnings, and they have the reinforced learning. The supervised learning is the very popular one is a classification, right? And we have the regressions. And in the unsupervised learning is the clustering the group, right? And dimensionality reduction. Okay, then dimensionality reduction is to let's say it's an application that want to summarize the instant data sets into the smaller dimension data sets. Okay, something like you have the dot in 3D, and you want to convert them to the 2D. Okay, you want to convert them to only the paper part. Okay, the dimensional reduction such as PCA, something like that. They shoot. They act as a knife, shooting something like the 3D is at the bread loaf. Okay, and then the PCA will thinking that which way that the knife cut can pass to a lot of points as much as possible to maintain the information as much as possible. So they cut something like this. So and then we got the 2D part of this bed loaf into the paper, and this is the dimensional reduction. It's very good for making for the 2D is much simpler way to represent the data, which maintain the accuracy of the data, which makes learning is faster. And the last part of the machine learning is the reinforcement learning. Is for something like you put some AI into the bad situation, something like you are the soldier, something like that. They are the dynamic, okay? They are the dynamic situation, so they need to make a decision with the limit information, okay? Something like in the game AI, right? The goal, alpha goal is as a part of the reinforcement learning, okay? Okay, this is the way to classify by input. And if you classify by output, okay, or classify by application, we have 5 ways to do that. This is a classification, already tell you. Regression is a predict stock market, something like that. Clustering is a cluster make separate group of data into the server group, okay? And the density estimation is for the file distribution, okay? It's for using the anomaly detection. If something have wrong, okay, something like you are the credit card companies and they have the fraud about 0.1% at a time, right? You can use this estimation to detecting anomaly detection that each transaction is fraud or not, something like that. And the last one is the dimensional reduction, is trying to simplify the input by mapping them into the lower dimensional space. Okay, so this is the output of the machine learning. And like this, classification, we have data, we try to cut them into the mini classes. And the clustering as well, we don't have the target data, they find the similar characteristic between instant, and it will stick together into it. And the regression, we see the pattern, something like that, we want what they're moving up and down. And anomaly detection, they will try to detect the anomaly. So something like outlier, they're trying to detect outlier of the group. Okay. In the machine learning, is the machine learning is very popular in the last 20 years, okay? And with the popular of the machine kernel, with the SVM and a lot of things like that, they can do it very well, quite well. But they have rely on something. The machine learning is very popular, but the most important thing they need to rely on is the features, okay? The feature extraction. The performance of this machine learning is depend on the representation of data that humans manipulatively input into the model. Okay, we call this part is a feature extraction. Okay, the something like for the in the logistics regression of the recommend of the delivery should be the operation or not. The doctor who is the take care of the case, they are the guy who inspect, who talking with the patients, who inspect the patients, and they input the system the several information such as but how much blood pressure, present or absent of the uterine scar, and a lot of information about this girl who are planning to deliver it. And each hidden information is called features, okay? And in the machine learning, they need human to extract the feature for them, okay? And so, as you can see here, is input is here, and we need human to feature extractions, and we then do classifications, and we got the output, okay? But in the deep learning era that we are going to teach you here, they want to cross out this part, okay, feature extraction. We give them the raw data and let the deep learning to extract the feature for themselves, okay. So as you can see, the AI is from the beginning of the AI till today is much better and better. Is rely less and less on the human intervention, okay? So because you know the human is very subjective for each data, okay? And if we let the machine to do it by itself, it's the best for us. And that is the limitation of machine learning, that human need to feature extract for them, okay? And another part as well, before we have deep learning, in many tasks, the feature is unable to extract, okay? Something like you got a picture of these things, okay, in the video camera, okay? You got video of this thing in your camera. How you can extract these features into input to the system, okay? Something like a car. We want to create the model that be able to object detection, the car object detection in the pictures. Okay, so if we are the data scientists, okay, and we take a look at the pictures and to make them detect this car, we need to manually tagging something like this is the wheel. I think this is the wheel. This is the windshield. This is the windshield. This is the light. This is something like that, and put into the system. Okay, and yeah, and then machine can be able to know that we have the car in the pictures. Okay, but in the video that 60 frames per second, at a lot of the 100,000 of camera today, if we want to detect the car in the camera, we cannot have the human part in this process, right? Because the human very slow when they tell to the system, it's impossible. So, and not just only it is the lack of the speed of the people, but it is very difficult to describe as well. What exactly what the view look like in the term of pixel value? Okay, so in fact the view is very the geometric shape, but I think it should be very easy to recognize, right? But in fact the image you can see they have the shadow. Okay, you have the shadows. We have maybe you have the sun gliding. We have a lot of the disturbance in the environment in the pictures that make the object recognitions like the wheel, something like that, is very hard to perform. Okay, so the feature. So this is make to you the conclusion that the feature that allow the human to even the human write down the code to detect this thing. Okay, to detect some part of the wheel to get the control of the car, it's still impossible because you need to human need to write down the feature extraction code to get in all situations of the picture possible. Something like if it is in a snow situation, right, and the light is very bright because the snow is white, the rule that you write down to detect the view of the car is mislead and become fail in some specific situation. Okay, so the human-oriented feature extraction is outdated and they have a lot of problems. So they have another guy said, okay, we want the machine to do this part for us, okay, and we call it representation learnings. Okay. Representation learning is, let's say you can see, right, if one thing happen, if the problem happen, okay, most of the bottlenecks of each AI is at the involved with the human part all the time. Okay, and to solve this, they inventing the machine to do it instead of us all the time. Okay, so at first we have AI, right? We have, if we go back to the first era AI, we need to write out a program to control them, right? Okay, we can do that. So machine learning do this. Okay, but we do machine learning, we need to extract feature for them. Okay, and right now extract feature for them have a problem because they are the weakest link. I mean, to make the program working perfectly. So the guy said that okay, it should not be human doing this. The machine should do the feature selection part for us, and it's become the representation learning. Okay, so to solve the problem, we try to substitute the human part involved into the experiment process. Okay, and then the representation learning is proposed and is trying to using the machine learning to mapping and the raw data into the feature that providing useful information. Okay, the first one of the kind of the representation learning algorithm is autoencoders. Okay, the autoencoder is a communication between combination between the encoder functions and the decoder functions. Okay, so we put the raw image into the encoder functions, and encoder transform the data into the different representation which have nicer property than the raw image, and then they convert back in the decoder function to the original image. Okay, so this guy, this autoencoder is the beginning of the representation learnings. Okay, so but the feature that encoded by the encoders, they need to have the enough information to that can describe the label card that we want to do classify applications. The goal of this thing is we want to design a feature which be able to separate the factor of variations that explain the observed data. Okay, so this is a very good example. Okay, so for example, if you have the data like this, okay, this data is represented by the Cartesian coordinate, okay, x, y, and the autoencoder, the encoder, find that if we change the representation in the Cartesian coordinate instead to the polar coordinate, okay, the polar coordinate is this guy is the theta, this is the theta, is mean the degree, how much is, this is the 0, 0, right? This is theta, and r, this is the length between this guy into the center point, okay? So we want to classify this into classes. And for example, this guy, okay, is all around into the circle, and is very close to the center point. So that's why in the R here they stick to the left. Okay. And this guy is the circle around 360 around the center point, but they're very far away compared to the blue. Okay, so the R here, so we are more on this. Okay. This case can be solved very good by the representation learning. So they just use the different representation. So to classify this in the logistic regression, we have the linear models that can draw only the straight line on the model. They cannot solve this successfully. But in this case, they just draw like this. It can solve successfully. Okay. So this is the beginning of the representation learning, and it can be in many form. So in the SVM, you can see the kernel for the SVM. This guy is transforming the representation of data. Okay, if you learn SVM before, you know that kernel is guy who transforming the representation of data. And this is the art of the representation learning. Okay, and then this is the beginning of representation learning, and after that. Okay, they're trying to they measure the data that they can do by running. Okay, so something like if you put the data and yeah, this can be human in the process because they can test by this. In fact, when they encode the data into the encode format, right? They can use the encode format as an input to the classifier and see the results. This is one part. And the second part, they can use something like measurement of how good of the feature is. They have something like that to measure. Depend on the application that you use. Okay, so the answer is possible two way. First, go try it in the real classifier. Or second, they have the metric to evaluate it. Depend on the application to use in that. Okay. Okay, and the representation learning is trying to convert by using some function, but they are not. It seems like they focus on only the single level transformations. Okay, the single level transformation. So when you have the input, right, and you have one function to convert it into some code, you have only one function to do that. Okay, you have only one chance to convert it. Okay, but in our worlds, like this, okay, we have the feature in hierarchy format. Okay, something like in the share, like this share. Okay, the feature to display the share to be different from the other objects. Okay, first, we need to understand the represented in the pixel value. Okay, in the pixel value. The share in the top hierarchy of the share is composed of 4 legs, okay, and the black, something like that, right? To understand that this part is a leg, they need to understand the border, the curve, the polar point, or something like that, to understand that this is the leg of the share. Okay, so in the lower level, this is the dot pixels that are representing the border, the corner, the border of the objects in the pixel level. So อธิบายใหม่ดีไหมวะ Okay. So let's say the deep learning is based on the representational learning. The key difference of the normal representational learning is support the hierarchical features. Okay. Like what is hierarchical features? Okay. First, something like these features. Okay. We want to classify them into the car, person, or animals. Okay. When we got the pixel value, okay, this is the lowest level of the visible layers, or we call it input pixels. Okay. The feature of become the human is okay, I will explain for the bottom to up is better. So we got a lot of pixels. Okay. And from these pixels, we can detect some edge, some corner, some point of each pixel to grouping to become the another features in the features. And then the edge, we can detect become the corner and contour, the specialized corner and contour for each features. And after that, this one of the corner and contour, combination of that become the each object part in the pictures. And finally, with the object part picture, we can obtain the object identities. Okay. So in the real world, the feature is have the hierarchy structure, right? This one is this is the son, this is the father, this is the grandfather, something like that. Okay. So they combining this feature together and become discover the feature that can describe the classification very precise and very high accuracy. Okay. So this is the beginning of deep learning. Okay. So the deep learnings can achieve this part because they can solving the feature extraction problem by introducing the representation that express in terms of other simple representations. Okay. Okay. If you compare to the previous representation learnings, they have only one layers. Okay. But this one can have n layer that you want to compare. They describe a feature by using the earlier layer of features and it's matched to the real world situations. And this is why the deep learning is become super popular because they can capture our knowledge in this world the best, very well. Okay, this is the best example of to understand what is the deep learning. Okay, and this whole circle is AI. Okay, and they have a lot of AI to do, including the formal task solver, something like knowledge base, something, or just simple programming logic rule, something like minimax, reverser, differser, some algorithm, something like that, is belong to some sort of outer circle of AI. And then, okay, this when people don't want to write the rule for the computer by themselves, they invent machine learning. Okay, the machine learning, they have the logic segregation, they give a lot of algorithm. Okay, and after that, but the human need to extract the features. Okay, they're lazy, so they want, and their work is very bad as well because the human is very subjective, right? So they invent representation learning. Okay, representation learning, they have a lot of that. One of them is the shallow autoencoders. Okay, and after that, the representation learning is still not good enough. So we need to supply them some process information. We want to supply them the raw information to make it work. So let's make them interfere to by itself in the hierarchy format. So they invent the deep learning. So example is a multi-layer perceptron, okay, as the algorithm for the deep learning. So let's say the human become lazier and lazier in its process, the invent of this AI. Okay.
And now we are lazy to label the data for deep learning.
Yes. Yes, in fact. But we still need to label the data. But yeah, I think somehow some people can improve it, that can make a computer that don't need to label the data at all. With understanding, I think it's the final state of the AI, but still not yet discovered. Okay. But if you can think that, it means that they can learn by itself, right? Without human intervention, yes, that statement is called singularities. That is the moment that the machine can discover itself and autonomously learning by itself. Yeah, and the human got destroyed, something like that. That's the next step, okay? And I love these figures. It's very clear, okay? The gray box here is the process that we need. Okay, I forgot. The shade box is not able to learn from data. Okay. So this is the beginning of AI. This is the rule-based system. Okay. We have the input and hand design program by human and become output. Okay. These are our programmer doing like this, developer, web developer, something like that. Do all doing this. Okay. And the second one is a classic machine learning. Okay. So we have input and human doing feature extraction for them, and then this one is computer part to doing it. Okay, the machine can do it first. In the shade part is a machine do it first, and we have the output of the design class. And the next two is the representation learning. The classic representation learning is we put input, and the machine trying to extract feature by itself, mapping on the features, and then output. But only one layer of only. Okay? But for the deep learning, they got the input. They extract a simple feature first, something like the border, the edge of the image, something for the sound, something like pitching level, something like that. And then they have the feature extraction, the additional layers for more extract features. Okay, and become the leg, become the plane, become the shape of triangle, something like that. And become the mapping for the feature and become the output of the class that we want to. Okay, so this is the step for deep learning. Okay, now you heard a lot of words about deep learning, right? They have a lot of the algorithms and a lot of things. In the previous section that I taught you, is to understand what is the deep learning position, what is the position of AI right now, and how is have a relationship to each other. Okay, and I want to have some sip of water. Okay. Okay. According to this rate, we will finish in 1 hour. Another 1 hour, I think. Okay. Good. Okay. Okay. We talk about history a bit. Okay. We want you to understand how this thing become invented. What is the beginning of the artificial intelligence and become deep learning today. Okay. Deep learning is super popular today. Why? Okay. Because of they have the following key trends. Okay. The first one, deep learning has long and rich history. Okay. It's gone by many names. Okay, something like cybernetics, something like cognitionism. Okay, you might heard. If you heard that, you are very old. Okay, it have long history and become actual useful nowadays. And the second one that the meaning become popular is it's become more useful when the amount of data available. Okay, we are entering big data era, and the deep learning is something like the killer for that. And the third one is deep learning model have grown in size over time. Okay, in something like Google Linet, something like that, is over 100 nodes, something like that. Okay, as a computer infrastructure, both GPU, hardware, software for deep learning is improved. Okay, so we got huge improvement nowadays. And the fourth one is the deep learning can solve increasingly complicated applications. Okay, and increasingly accuracy over time. Okay, I typed out too fast, so here, fixing it. Okay. And the history of AI, okay, especially for the neural network, okay, have three waves. Okay, the first wave is called cybernetics. Okay, it started at the 1940s. Okay, and then it ended in 1960s. Okay, and then after that, no one interested the neural network for 20 years. Okay, and after that, they also spark again under the name of cognitionism. Okay, and started in the 1980s and last to the 1990s. And then they down again because of the rise of the SVM and kernel machine and graphical model, something like that. So, but after some guy, Hilton, I think, to create the deep belief network, it's become boom again in 2006. And under the name deep learning until today. Okay, if you take a look on the Google keyword search in the books, okay, and in 1940 they don't have Google, right? But they use Google to detect it. The Google have a lot of the 1,000 books with the word already. So the guy, the Elon made this graph by searching the keyword in the Google books and back to the history. They found that the cybernetics is become very popular in almost in the 1970s. Okay, the number of work that they found in the books in the beginning of 1940s, and then still behind that. And then in the boom of the second wave, the cognitionism work is start beginning at the mid 1980. Okay, this is this year that I born. This is the year that I born. So it is become more and become like that. Okay. Okay. The cybernetics, the first wave of neural networks, is beginning at the 1940s. Okay. The earliest predecessor of the modern deep learning is the simple linear model. Okay, is motivation from the brain cells. Okay, from the neuroscience. Okay, the model is designed to take the set of input layers and associated with the output layer, and it's called the cybernetics. Okay. The first one is but this is the image of the artificial neural network. It's not yet fully. At that time, you not have looking like this. Okay. It's much simpler than this. Okay. Macro pit neuron is something like neural network. It's just linear models. Okay. That trying to classify to class. Okay. And they have the input like this. We have the input layer, right? We have the input layer, something like one or two of that, and Macro have, and then they still have this concept as well. This is the way as well, and they have the output. Okay. The Macro pit thinking that if the weight it can be set correctly, they can from the input they can answer to the output that we want. Okay. So at the macro pitch thinking about neural network, they did not have learning thing yet in this network. They just let human take a look at the input and output and write down the number in the way, and hopefully they write down to the correct way, and then we got the model of some thinking machine. Okay, at that time we start like that. And then after that, this pen is not good. After that, the Persenton, okay, in 1950s, okay, they can start learning the way, okay, by using the linear models, okay. So something like I still not much clear, but it's something like we have x1, x2, right, and y, something like this, and then they're trying to write down the all function, something like that, like this, and then they claim that without the human assignment, we just simply input them the input and the output, and the weight is and the weight is defined, and the weight is defined from each category. So something like if these two have this y, right, they're gonna have to use the predefined weight 1 and weight 2, something like this. So they can know that if we use different weight set, it's gonna be affected output. Okay. So, but it's still not read this paper, but it's very old one. And they concept that they are trying to getting to learn to the way. Okay. And then the next one is very, very clear that, but it's only the linear models. They try to learn from it, but it's not yet the gradient descent. Okay. And after that, the guy using the Hoff, okay, the Hoff proposed that this learning rate can be done stabilizedly by using the stochastic gradient descent. Okay, this is they call this method is called analyze. Okay, so they're trying to set the output, for example, in this part, right? This is the OR gate, right? So when we put something, right, 0, 1, right? And then we got 1, right? They propagate the value of 1 go back to the way directly without taking the derivative. Okay? So this is the simplest way to the stochastic gradient descent to get the propagations. Okay? But they support only the one layer of it only. Okay, so at that time they don't have two layer of it. They only thinking about weight in the one layer. Okay, so they think we let's format the output to update the weight and something good happen. Okay, that is the analyze. Based on that, okay, in the 1960, some people estimate this one, and they say that since this way, right, we have is a linear model, so something like x equal to, y equal to x1 w1 plus x1 w2, something like that, x2 w1 plus x2 w2, something like this. This is the linear model. And they don't have the concept of minus at that time. These analyze cannot learn the XOR functions. Okay. So the XOR function is if we got the same number, we got 0. If we got different numbers, we got 1. Okay. Since is always additive at that time, no minus concept at that time. 1 would never become 0 based on this model. Right? And the neuroscientists at that time know that this thing in the brain can be done happen. So this model is wrong. And this is the main reason of the losing the popularity on the first wave of the neural networks. Okay? So they say that this is linear models and they have many limitations, and the most famously is cannot learn XOR functions. So because they have some researchers say that it is not matched with the biological brain, because biological brain can learn this pattern. So it's become the major dip in the neural network at 1960. Okay. The neuroscience, the AI, normally they trying to all of AI researchers in the neural networks, okay, they inspired by the neuroscience a lot, okay. But at that time, they have another approach to learn about, to creating about the deep learnings based on the knowledge of neuroscience. Okay, they're trying to mimic the brain functions into the computers. They have some researchers who want to do that. But at that time, we still don't have enough information. Until nowadays, we still don't understand what our brain doing. Okay, so we simply don't have enough information about the brain to use as a guide. So to make it really understand, we need to be able to watch the activity in our brain, 1,000 of the interconnection neurons simultaneously, to understand them. And nowadays, we still cannot do that. Okay, so that's why the neuroscience-based approach is not so popular, because the neuroscience itself is not yet understand the brain well enough. But a lot of our deep learning research work is derived from the rough guideline from the neuroscience a lot. Okay, this is the clear example. The first one, the neocognition, okay, is found by the Fukushima. Okay, this is the mobile architecture that process image from the guide with a doctor to understand the eyes and the brain visual image. Okay, this knowledge, this paper, is the father of the modern convolution networks. Okay, in CNN that we use in deep learning today. Okay, even the neuroscience is not helpful much, but they give us some rough guideline from the neuroscience researcher. Okay, and the second one, something like the activation function that you will learn in the next week. Okay, activation function. The most neural network today is based on the model neural called the rectifier linear unit. Okay. The identifier unit is the activation of the brain wave. Okay. Let's say like this. It is very helpful in the deep learning. Okay. It's developed on cooperating idea for many viewpoint citing from the neuroscience. Okay. So the neuroscience, in fact, is a big. It gives us a big clue for the neural network, but they not give us the clear path to do it because we still not yet understand our brain. That is the main reason. Okay, after we have 1940s, we have cybernetics, and we down because we cannot run XOR, learning XOR in 1960. In the 1980s, okay, it's become another popular boom. It's called connection distance, or the power dispute processing. Okay. The connection distance, in fact, is become popular from the cognitive side. The cognitive side is the multidisciplinary field that consists of mind, brain, electricity, the engineer, a lot of things. Neuroscience is something like scientists who want to understand the brain, but the cognitive side is something like the engineer of the brain. Okay, they need the interdisciplinarity. They need to know the neuron size, and they need to know the engineer. They need to know a lot of things to become the cognitive science. Okay, the cognitive science movement in 1980 is very popular at that time, and they proposed the connectionism model. That the connection model is the large number of simple communication units can achieve intuitive behavior when they were together. Okay, so the connectionism concept is like this. This is the wave, right? This is the wave, right? Okay. At the first wave of the AI, at the semantic wave, for example, if you want to classify the three objects, something like we have an apple, okay, we have the apples. This is the red apples, and then we have the glasses. It has the blue glasses, like that. And then we're gonna have another thing. I have the black one, right? So it should be a shoe. Okay, a shoe. We have three objects to classify. In the before the connectionisms, when we're learning, right? We might put a lot of features, and we might put that this is maybe the color. This is the shape, right? Okay. Before the in the cybernetics, we have three shapes, right? So we might have to detect this kind of this with this color and shape features. We need to create the brain neuron to be able to activate when we got the shape of apples and red color. Okay. And then we need to have the shape of glass with the red colors, and we have neuron is activated when we have the shape of shoe with the red color. Okay. And then we have another one is something like we have the shape of heart again with the blue color, glass in the blue color, and the shoe with the blue color. And the last one, we want to have the black color, and we have the glass in the black color, and we have the shoe in the black color. Okay? So black color. Okay. And at that time, when you want to detect this thing, right? You just checking, if this is apple right, not hard. Okay. When the people detect this thing, this way should be hard, right? And this another thing it should be zero. Okay. And according to this way is very high, so we can know that this is the great apples. Okay? So the cybernetic period, they think that for each combination of the features, they need to have a way to respond for that. Okay? But for the conditionalisms, with the statement of large number of simple condition unit connection intelligent behavior will never together. So they think that why we need to do this is too much. Okay, we have 2 feature trees and we got 9 model to use, right? 9 neural to use, right? Why we not just use something like this? Instead of all of this, we just need only these 6. Okay, and then the first one is a color. So we have the neural that respond to the red color, neural respond for the black color, and neural respond for the blue color. And then we have another class neural that respond for the shape, something like apples, the glass, and the shoe. Okay, and then they say that we networking together. This is the concept of conditionalism. To convert from every node for every possible values to become the layer of its features and connectivity between it. Okay? So this is it's called the distributed representations as well. Okay? Yeah, okay, you understand that? Okay. This is the distribution representation is here by Newton. We said that the idea that each input system should be represented by many features, and each feature should be involved in the representation of many possible input like this. Okay, so and in the beginning, right? In the beginning, we said that in the each separate neuron have estimate for each 9 possible combinations. Okay, but the another way to improve that use this representation that using 3 neurons to describe the color and another 3 to describe the object identities, something like that. And instead of 9, we use 6, and this combination here there are a lot of possibility to detect the classifications. And let's say the main difference between the first wave and the second wave is the number of layers. Okay, the second wave increase the number of layers in the representations. After that, when normally in the first wave they have only first layer, right? They don't need to have back propagations because back propagation is not needed, right? Because we have only first layers. They just bring the value back and minus the weight directly. But instead of that, we have many ways, we have many layers in the neural network. So we need the back propagation algorithms, which is the dominant approach in the deep learning today. Okay, and be able to train the neural. So when the output have something like this, and we be able to migrate the learning parameter back to the earlier layer. Okay, this is called back propagations to the earlier layer and update the weight accordingly. Okay, you will learn very soon in the next week. Okay, back propagations. And after that, and we have the very interesting invention here in 1987, and it's called long short-term memories. Okay. In the neural networks, it is very bad at sequence models. Okay, neural network is something like you send them the snapshot of the pictures to the neural network, and neural network recognize and identify that clearly. But if something in a sequence, something like spoken word, okay, something like website, the sound, okay, when you put to the neural network, the information in the previous second is not helpful at all in the current second. Okay, so neural network is not yet suitable for the sequence models like text, like like the sound or speech. And the guys, and it's very hard to pronounce, I don't know, it's German, I think, is invented LSTM, the long short-term memories, to be able to use the neural networks to apply for the sequencing models, tasks, something like the machine translation, something like the wire conditions, something like that. Okay, they're using the LSTM to solve the fundamental mathematical difficulty in the neural network for the sequence models. Okay, and this one really useful in the RNN neural network. You will learn it later. Okay, and after that, and in the mid 1990s, the neural network is getting very popular at that time because of bad propagations, and they can start to see something happen. Okay, I remember in 1990, they have some guy who want to do the autonomous driving car by using simple neural network. Okay, but it is okay in the field test, but not impossible in the real situation. I still remember that video. Okay, they have some guy using neural network to start driving a car in the test drive lane. Okay, but it's not good enough for the production use. So the venture, the guy investor in the Silicon Valley at that time, 1990s, Silicon Valley exists already. Okay, and alternate technologies began to make unrealistically ambitious claims while seeking investment, but none of them can done perfectly. Okay, so the investor was disappointed, so they pull out the fund. So a lot of projects is closed down. And in the same time, other fields of machine learning makes advanced something like kernel machines, graphical models, will achieve good results in many important tasks. Okay, so it leads to this decline of the popularity of neural network in 2017 until 2017. Okay, so about 90, we don't have the good applications of neural network much. Okay, and after about it's declined about 1995, I think. And for about the 10 years, in the 2006, we got boom of the deep learning. And I will sip water a bit. In the 2006, the Hilton, okay, Jeffrey Hilton, okay, they show the kind of a neural network called deep belief network. Okay, deep belief network is this algorithm is sparking deep learning. Okay, this is breakthrough of the first wave. Okay, so the deep learning is deep belief network is something similar in the representational learning. Okay, without guiding of the human, as I said earlier. This is the beginning form of the deep learning. Okay, they use the deep belief network that uses something called Kobkrit Viriyayudhakorn pre-training. Okay, so they don't need to providing any feature to them. Okay, and result is quite good. They can increase the accuracy of many applications. Okay, and then a lot of people follow up. Okay, the CFAR. Okay, the CFAR. This is the name of the research group. We're very active today in the deep learning. Okay, they quickly show the same strategy to train many kind of deep learning network. Okay, and it can test that it can help the accuracy of all machine learning tasks in many domains. Okay, they prove that use this deep learning network before you, instead of feature extraction normally, you get very high accuracy. Okay, and then they become very boom because a lot of the neural network, a lot of machine learning competitions, something like the ImageNet, okay, the ImageNet, and we'll open the Google for you. ImageNet competitions. The deep learning taking the first rank, start taking the first rank from the 2007, I think, and they stick to the first rank all the times. So the researcher throughout the world, oh shit, deep learning is real, it's coming, okay. So they have the ImageNet competition like this, and they normally have the, I don't know, the deep learning is taking the number, the first rank all the times for about 5 or 6 years already, and make the people very boom about deep learning. Okay, go back to this one. And since the deep belief network have the very deep weight, okay, layer, so this wave, the popularity of the word deep learning is to emphasize that researchers will now be able to train deep learning network than before. So it's become focus attention in theลองถามไม่แต่ต่อเขานี่ชั่วโมงครึ่งเหรอวิชานี้เรียกไหนครับวิชาที่3 ชั่วโมงมีห้องเรียนมี2 บ่าย 2 ครึ่งตายละมีส่งเขาจะมาใช้ห้องนี้งงเลยไม่ทราบใช่ไหมนาริสลานี่คนที่เขาเป็นเลขานี่เขาชื่อเล่นว่าอะไรนะพี่ปาปะเขาชื่อพี่ปาใช่ไหมปลาทำมาฟิชใช่ไหมโอเคฮัลโหลสวัสดีครับคือเขาบอกว่าอีกห้อง3206นะเขาจะมีอีกคลาสหนึ่งมาเรียนนะครับตอนบ่าย 2 โมงครึ่งเขาบอกให้ผมต้องออกผมงงเลยนี่ไงคุยกับเขาได้ไหมอันนี้ได้ครับยังไงดีล่ะเดี๋ยวให้เลขาเขาเคลียร์ครับเพราะว่าผมไม่เพราะว่าเขาตัวเลขาไปจองกับฝ่ายเอเอซึ่งไม่ใช่ผมคนจองให้โอเคว่าให้เขาเคลียร์โอเคครับถ้างั้นเอาไงผมสอนไปก่อนแล้วกันจนได้ความอาจารย์เขารอเหรอโดนยึดห้อง จองมาได้ไงวะโอเคไม่ใช่ละมีอะไรโชว์เยอะเลยสนุกดิวเลอร์นิ่งเนี่ยสนุกมากโอเคไปเร็วๆหน่อยดีกว่าเรายิงเหลือเยอะเลยเดี๋ยวไม่ทันโอเค so this is the beginning of the third wave นะครับ and the factor that deepening popularity is a lot of things the first one is nowadays we have a lot of data set okay if we got more data the computer got more knowledge captures is more intelligence in more accuracies and you can see the trend this is the algorithms in the neural networks that this is not it's the data sets available for the machine learning they increasing in size according to the probability here and we have the data set size is a factor of 10 and you can see that is increasing this way the people using the mobile phones, here the data, log entry every day, a lot of picture taken, right? And a lot of computer digitals. We have huge amount of data to process. This is the MNIST dataset. The MNIST dataset is the dataset of handwritten digit numbers. It's used for the post office of America to automatically detect the postal code. And the MNIST it stands for the National Institute of Standards and Technologies. But we have M because of it stands for modified. They cleaning the data to become clean and very good to use. And the MNIST data is the most popular data set in the world. Okay, it's something like hello world statement in your programming. Okay, the MNIST is the hello world in the data science. Okay, you need to learn it about it and trying to understand. Okay, and we have the increasing model size. The neural network, the model size have much higher connection per neuron. Okay. If in the brain science, in the brain here, in the human, one neuron have the connection with another neuron about 1,000 of it. Okay, 10 powerful. No, 10,000 connections. So one neuron in the human brain have the 10,000 connection with another 10,000 neuron. Okay. This is the human knowledge. And the neural networks also increasingly increase the number of connectivities. Right now, in the number 9 here, the average, the cat, this is the cat intelligence. Cat intelligence. This is the logarithm. This is logarithm degree. So the cat is, I think, is very about similar to human in terms of logarithm. And you can see the number 9 algorithm here, which is the HPC white correlation network here, is be able to have the brain size as a cat. Okay, nowadays. Okay. And you see the fruit fly here, the mengwan, mengwi, have the connection per neuron is only 100. Okay. And the mouse have about 1,000. And the cat have about almost nearly the human is 10,000 connection per neuron. Okay. After I know this number, I understand how hard it is for the become the brain surgery. So it's very hard. Hello, สวัสดีครับคุณปา โอเคเยี่ยมมากครับขอบคุณครับOkay, we got the room back. Good. We stay still at the end. Okay, and then more clarity is mean more children. Okay. And due to ability of faster CPU right now, we and the advent of the general purpose CPU, right? NVIDIA, AMD, something like that, GTX 1060, something like that. If you're having one, you can training the data very fast, so your model is become bigger and bigger and more intelligent. Okay, and here is this is the number of neurons. Okay, that's what is number of connectivity per neuron. Okay, this is number of neurons in the container. Okay. Human have about billion, right? Million. Okay, it's 10 power 11 number of neurons in our brain. Okay, so we become this intelligent, this intelligence. And you can see our nowadays AI, they have the instant as about between B and Fox right now, and the same manner B and Fox. Okay? They project that in 2056, the AI algorithm gonna be same level as the human. Okay? In terms of number of neurons. Okay? So this number one is the perceptron, okay, that I teach you, perceptron, and they are keep increasingly more intelligent nowadays. They increasing in the number of neurons, and they better in the accuracy. This is the decreasing error rate over time of in the image large scale visual recognition contest. Okay. In the 2010, this is average classification error is about 25%. And then in the 2015, the error rate become only 5%. Okay, in the average total error in the competitions. This is showing that this is the higher neuron, more advanced algorithm, creating lesser error rate and high accuracy nowadays. And giving more and more applications. This is I write down the very popular deep learning algorithms nowadays. And you will learn in the course CNN, RNN, GAN, if possible. Okay, these 3 things. Okay, you will learn this. The first algorithm is called convolution neural network, or CONNET. This is the class that very successfully in the analyzing image. Okay, you will learn very soon. And the second one is the generative adversarial networks, or GAN. Okay, it could be learn the output of the entire sequence of characters described from the image. They can generate some things. Okay. Okay. The best way to do this, I will gonna to open the video for you to show you. I think if you go back to the first video, I forgot to play it back to you, and you see that what deep learning can do it today.
It all begins from a single origin, a unique point in space and time. This
I want full screen. How can I do it? Go to YouTube. It's a better way.
is the spark of innovation that fuels your most amazing breakthroughs. It's a passion for discovery that unveiled the genesis of all that exists in the universe. Today, the power of AI helps computers achieve superhuman capabilities in image recognition and lets scientists save our most precious resources by analyzing in 1 month what used to take 10 years.
是谁发明了机械计算机？
Everyday devices translate even the most complex languages from voice into text and images into words,
Xavier is now present.
helping the visually impaired recognize an old friend, or letting a blind woman read to her child for the first time. Autonomous vehicles give us the freedom to reimagine our city streets and travel where there are no streets at all to help the lost find their way home. We see robots teach themselves to perform simple tasks.
นี่เรียน for learning นะครับ
We even watch in awe as they take their first steps. And today, a 2,500-year-old game meets its match as a computer competes with one of the greatest human champions of all time and wins. This is the collective imagination, fueled by forward-looking technologies and the beginning of your most amazing discoveries yet to come.
นี่ NVIDIA นะครับวิดีโอนี้มันแกนดีมากเลยผมเลยมาเปิด เดี๋ยวเข้าใจภาพรวมนะครับโอเคลืมไปว่าต้องภาษาอังกฤษโอเค โอเค go back to the CNN นะครับ CNN I gonna to turn on what does CNN look like okay the CNN here is the very good for the detecting the image and videos okay something like this is the video image for detecting the object in a real time movie and this is the CNN okay the useful and that and okay let's complete this I think it's about 1 minute they can detect car they can detect the traffic light a lot of car here okay this is a CNN นะครับ if you want to do something like this study CNN okay not the news channel นะ okay it's collision neural networks and the second one is the generative adversarial network it can be in fact it can generate something from the input they using the discriminator and the generator model script, which you will learn in the past midterm meetings. The GAN can formulate everything, including sound, including video, including image, something like this. This is the product of INN. They can formulate the video of horse to become the zebras. Okay, they're learning the style of the zebras, and then they're trying apply to the video image. And the scan, they have two sub-networks. It's called discriminators, which trying to catching the fake image. And the factor, the guy who make the fake image. Okay, they're training the both network all together trying to train the fork in network to be able to fork the image that very realistic until the discriminator cannot catch the frog image. Okay, this is the GAN. Consists of two sub-networks holding together. Okay, and the GAN here is very good as well. This is the input pictures. This is the output pictures. Okay, sorry. This is the test set. Okay, this is the test set. Okay, this is the input pictures. Okay, they don't know about this. They don't know about this. Okay, they can transform the slight eagle face to become the straight face automatically without knowing this test level. This is the GAN. Okay, usually let's start reading GAN. Okay, but I will show you in the after midterm if I can with Dr. Pui. Okay. So they can convert from the slightly like this and become the straight face automatically. And really realistic. This is a realistic picture. This is the temporary pictures. It's the same thing. Actually the same things. You feel right? Okay, this is the GAN. And then the next one is the recurrent neural networks or RNN. Okay, it's used for the sequence. It's used for the model relationship between sequence and the other sequence. Okay, is very good for the time domain sequence models. Something like I'm gonna go show you here. They have a lot of things that can do. The RNN can do a lot of things. Something like the language understanding, the machine translation, the music generation, the stock predictions. So when you put in the sequential data, you need to do it with RNN, okay? And then it can do something like this. We put the the list of knowledge into the computers. And the number one, number two, something like this. This is the knowledge I provide to computers. And then when we ask the RNN where is Mary, the RNN able to answer us, Balloon. And then we do it again, we supply them the two new input. And then we say that where is Daniel, is hallway. They can do understand like understanding in the text and sequence. Okay? And in fact, the RNN is very super
Dear fellow
helpful
scholars,
in
this is 2-minute papers with Carlos.
in the
Artificial
sequential
neural
models,
networks
something
are
like
very
this.
useful tools that
I
are
will
able to learn and recognize objects on images or learn the style of
okay, lose
Learn
this.
the style of Van Gogh and paint
They can
pictures
transfer
in
the
style. Today we're going to talk about
the
recurrent
artist
neural
style
networks.
into
So
the
what does
image.
the recurrent part mean? With an
The RNN
artificial
is
neural
used for
network, we usually
transform
have
one
the
thing
one-to-one
to another
relation
thing.
between the input
Okay?
and the output. This
It's
means
like
that
machine
one image
translation.
comes in and
It's
one
like
classification
transfer
result
image,
comes out.
something
Whether
like
the image depicts a human
This is
face or
they are
is
going to
sentiment
tell
deal with many
the-
input sentence and
but I will go to
after
go to the
reading
application.
Tolstoy's war algorithm is not a lot. The results are well.
This is
The
the
initial results are
bot. This
well,
is the AI. They're trying to
gibberish.
create the
But the
Shakespeare
algorithm
novel.
seems to recognize immediately
By reading the
that
Shakespeare
words
novel
are
and they
basically a
generate
big
it.
bunch of letters
This
that
is the
are
first
separated by
iteration.
spaces.
This is the output.
If we wait a bit more, we see that it starts to get a very rudimentary
And then when you learn it
understanding
more
of
and more, it
structures.
becomes more
For
readable.
instance, a quotation mark that you have opened must be closed, and a sentence can be closed by a period, and it is followed by an uppercase letter. Later, it starts to learn shorter and more common words, such as fall, that, the, for, me. If we wait for longer, we see that it already gets a grasp of longer words, and smaller parts of sentences actually start to make sense. Here's a piece of Shakespeare that was written by the algorithm after reading all of his works. You see names that make sense, and you really have to check the text thoroughly to conclude that it's indeed not the real deal. It can also try to write math papers. I had to look for quite a bit until I realized that something is fishy here. It is not unreasonable to think that it can very easily deceive a non-expert reader. Can you believe this? This is insanity. It is also capable of learning the source code of the Linux operating system and generating code that looks quite sensible.
โหดมากอันนี้
It
น่า
can
เรียน
also
มาก
try to continue the song Let It Go from the famous Disney movie Frozen.
นี่มันแต่งเองนะครับ
So, recurrent neural networks are amazing tools that open up completely new horizons for solving problems where either the inputs or the outputs are not one thing, but a sequence of things. And not
ก็คือถ้าเป็นเรื่อง if it's about sequence of things go to RNN okay novels music stock predictions okay is okay and then go back to this one this is RNN okay and then the last one is about neutral turing machine is similar to an okay and let's go back to the reinforcement learning. The reinforcement learning is the autonomous agent that learn to perform a task by trial and errors without any guidance or from the human operators. Okay. For example, like DeepMind, they are using the reinforcement learning. They're trying to matching against itself and keep improving by itself. And this is a reinforcement learning. Okay, so
Go is the world's oldest continuously played board game. It is one of the simplest and also most abstract.
Beating a professional player at Go is a long-standing challenge of artificial intelligence.
this is a movie about AlphaGo.
Everything we've ever tried in AI just falls over when you try the game of Go.
The number of possible configurations of the board is more than the number of atoms in the universe.
AlphaGo found a way to learn how to play Go.
So far, AlphaGo has beaten every challenge we've given it, but we won't know its true strength until we play somebody who is at the top of the world, like Lisa Dong.
A match like no other is about to get underway in South Korea.
Lisa Dong is to Go what Roger Federer is to tennis.
Just the very thought of a machine playing a human is inherently intriguing.
The place is a madhouse.
Welcome to the DeepMind Challenge. The whole world's watching.
Can Lisa Dong find AlphaGo's weakness? Is there, in fact, a weakness?
The game kind of turned on its axis.
That is not a confident face.
It's developing into a very, very dangerous fight.
All the fun. Leaders left the room.
In the end, it is about pride.
I think there's something went wrong. Yes, it's got lots of miracles.
These ideas that are driving AlphaGo are going to drive our future.
This is it, folks.
Okay, okay. That is all the popular algorithm that you have seen evidently in real world today. Okay, and before we are going to finish this introduction of the deep learning here, so I want to represent you the software, the library that we are going to give you the good example. We have a lot of the software infrastructure for the deep learning. The first one is a Terminals. Is a very popular one. It's written for the Python, and the Torch. A lot of people using as well is using the programming language. If you love to, and the second one is the Cafe and Cafe Tools is very popular from the UC Berkeley. It is written in C++ but using the Python interface. Okay, and the most popular one nowadays is TensorFlow. It's an open source library developed by Google, who are representing the graph node. The tensor here is mean when you have 1D, right? When you have 1D, we call it vector, right? The one-dimensional number sequence, we call it vector, right? And if we have two-dimensional, we call metric, right? And if we have three-dimension or more, we call tensor. Okay, it's called tensor. TensorFlow is mean the number more than three-dimensional flowing around into the into the mathematical operations. Okay, that's why it's named TensorFlow. Okay, and the very popular one is developed by Google, written in C, and have the Python interface. Okay, so in this part, in the deep learning and data science, you need to learn Python. Okay, you need to learn using Python to coding, and this guy as well. This notebook here is based on Python. I'm writing Python code for granted. So our class we will based on the TensorFlow with the Python. Okay, that is that. And another one is a class. Class is the attention based on Torino here. It have a simple interface and very popular in the sequence modeling in the RNN. Okay, but by the way, we use TensorFlow anyway. Okay, and the summary, the deep learning is an approach for the machine learning. Deep learning is an approach to the machine learning that draws heavily on our knowledge of human brain, statistics, applied math, and it developed over past several decades. Okay, developing of deep learning here is the very has seen tremendous growth. I forgot to speak a lot. Seen tremendous growth in the data sets and technique to train the deep network. Okay. The year ahead is full of challenge and opportunity. Okay, to keep deep learning even further and big new frontier. So that is the introduction of artificial intelligence and deep learning for today. Okay. So the next week I will starting teaching on the linear classifiers and persistent algorithms. Okay, so it's quite require the knowledge of the linear algebra. Okay, linear algebra. If you have time, please prepare yourself for the linear algebra. Okay, so we're gonna to use a lot of linear algebra in next week. Okay, it's quite heavy math. Okay, and we will coding all together. Okay, so for today, it's a 3. Okay, so this is the introduction. So anybody, you have any question for the first lecture? You have any? Okay. So if you don't have, okay, if you want to ask me some questions, you can contact me via this email. Okay, kobkrit@gmail.com. You can send me any question. I will try to respond within 1 day. Okay, to answer your questions. Okay, so that's all for today. Okay, so thank you very much for the first class here. And I think I need to check the name for the guy who enrolled this class. The four of you come all together, right? Okay, so Parinya, Puvapat, Naran, Rong, Natawat. Okay, good. So I will check it. So we check the attendance start from here. Okay, so you have the 10 score for the attendance. Okay, good. Okay, next time, if possible, please don't forget to bring your laptop, because it's better to have for you to have the laptop and open this collaboratory file altogether, and you can run the neural network by your own. Okay, while I'm teaching this. Okay, so we will explain the mathematic sequence, so on, and we are doing it together. So next time, please bring the laptop. Okay, and it's very good to just the paper. Okay, so for today, thank you very much. Okay, see you next week, and have a great day. Okay.
ไม่ต้องติดตั้งอะไรเลย
ไม่ต้องติดตั้งเลยเหมือน Google Doc เลย
พวก TensorFlow อะไร
ไม่ต้องมีอยู่ใน Google ผมใช้ Google Cloud หมดเลย
แต่ต้องเรียก
มันให้อยู่แล้วแต่ก็ต้องไปเรียกเดี๋ยวผมมีสคริปต์เรียกอยู่ทำตามสคริปต์อ่ะ นชื่อซะหน่อยไปดีกว่านะเอาไปซ่อมรถที่เหรอต้องมาประชุมกับอาจารย์โอเคอาจารย์ให้ไปซ่อมรถแอบไว้บอกว่า
อาจารย์สอน3 ชั่วโมงไม่เบรกเลยนะอาจารย์ไหนนะ
เซ็นติ๊กถูกมันใครก็ติ๊กได้ไหมเหรอเอาละเซ็นไปแหละ